So hello everyone. Today's question is closest prime numbers in range. So let's deal this question as per. Let's start the timer here. So the question says, given two positive integers named left and right, find the two integers num1 and num2 such that left less than equals to num1 less than equals to num2 less than as equals to right. Both num1 and num2 are to be prime numbers, and num2 minus num1 is the minimum amongst all other pairs satisfying the above conditions. Wow, this is something tricky. See, we are given uh, two numbers. One is left, one is right, and we need to find out two numbers. One is num1, one is num2, and the thing is they should be prime numbers. That's okay. And then they are saying that the difference between num2 and num1 should be the minimum among all the pairs that are possible. Okay, so now let us see what else are there. Return the positive integer array nums1 and nums2. If there are multiple pairs satisfying these conditions, return the one with the smallest num1 value. Okay, if no such numbers exist, return -1 -1. Okay, let's see example 1, 10 and 19. Okay, what are the prime numbers between 10 and 19? They are 11, 13, 17 and 19. Inclusive of 19. So the closest gap between any pair is 2 because 11 13 has 2, 13 17 has 2, 17 19 has 2, which can be achieved by 11 13 or okay. Since 11 is smaller than 17, we return the first pair. Okay. So basically, the first task that we're gonna do is find the possible prime numbers in given range. So after figuring out the positive numbers in the given range, the thing that we need to do is find the possible pairs. Possible pairs so that the difference is minimum, and then if same if pairs with same difference occurs, if pairs with same difference occur, take the one with smallest num1 value, and that's done. So this is how our approach can be. Okay, now let us check how we're gonna do this. Even I don't know how to approach this question. Um, so first thing is, what's the prime number? The prime number is a number which has factors none other than 1 and itself. Factors 1 and itself. Okay, that's cool. Now, how are we gonna figure out the prime numbers between two numbers? Hmm, First thing we can do, a brute force approach would be take a for loop between the numbers, just like how I am going to write. For int I is equals to left, I less than equals to right, I plus plus. Now, if let me take an array list integer is equals to new array list. So now, after taking this, if I is equals to left, I less than equals to right, I plus plus. Okay. If we need to check whether the given number is prime or not. Okay. If I is prime, of I, then a dot add I. Okay, so if it is prime, we're going to add into the array list. And let's see this. Num1s can be equals to left and can be equals to right. So the loop should start with left and end with right. That's good. Now let's write the method for is prime. Public boolean is prime. And what is the input? Int number. And if a number is given, we need to check whether it's prime or not. For int I is equals to 0, I is equals to, okay. What is the definition of a prime number? If a number is, uh, let me write it here. So it should have 1 and no other factor. Okay. Boolean result equals to true. No, let's consider it false at the beginning. Int I is equals to 0, I less than, we can write square root of n. Okay, let's take n, square root of n is okay, but we can take n by 2 also. So let's take n by 2 for now. I plus plus, and I mean here num by 2. And let's check if num, okay, num mod. So if we want to check if a number is a factor or not, see, the thing is, we should not check 1 because 1 will be a factor of every number. So we should check 2. And if num, hmm, okay, if num is divisible by, so num mod I equals to 0, then uh, result will be false. Let's take it true. Let's take it true for an instance. So if any number is divisible, then it would be false. So if a number needs to be prime, it should either be divisible by 1 or divisible by the number itself. And we are omitting both of these conditions. If still it returns false, so we can return result here. So now if it is prime, so this will automatically uh, basically returns whether the given number is prime or not. Now consider 2. If we keep 2 here, I less than num by 2, that's not possible here. I mean, so let's take it like this. I mean, if the given number is 2, it is already a prime. If the given number is 3, it starts from 2 to 3 by 2 is 1.5, which creates an error. So let's take I less than num. So that would actually follow up the edge cases. I is equals to 2, num by 2 equals 0, then false. So let's write edge case. Okay, let's take it from if I equals to 3, I mean this. If num equals to return true. Okay. If num equals to 3, it starts from 2 to 2. Yeah. I is equals to 2. 3 by 2 is not 0. so it won't return anything. So I think it works now. Next, from the given array, I mean array list, we need to figure out the pairs whose difference would be less. Is it maximum or minimum? Minimum amongst. So generally, the numbers which are consecutive have the minimum difference. So let's do one thing. Hmm, what we can do? So we just got the prime numbers between two numbers. Find the possible pairs. Do we need to find the possible pairs? If so, we can do actually one thing. See, since we have got all the prime numbers in an array list, we take the adjacent difference and okay, we do one thing. Mm, we take a variable int min diff equals to 0, or we can take integer integer dot okay, leave that shit. We can take it 0 because all those are prime numbers and prime numbers are positive here. They can't be negative. So let's take the minimum difference to be 0. So we can do one thing. Uh, we can actually take int latest is equals to 0. Now, for the first iteration, what shall we do? We need to track the adjacent difference, compare it with the minimum, and return, right? So, how to track the difference of all these prime numbers by splitting them into pairs? The question is, do we need to split them into pairs to take the difference? Or is there any way that we can actually track the difference without splitting them? Let's check. See this example. The prime numbers between 10 and 19 are 11, 13, 17, 19. So 11, 13, 17 and 19 are the prime numbers. And now 11, 13 difference is 2. 13, 17 difference is actually 4. And 17, 19 difference is 2. So both of these differences are 2. And then we are taking the difference, the num1 which is less, which is 11 in this case. So we can do one thing. We can actually create a hash map that stores the pairs as well as their difference. How is it? We store the pairs as well as their difference. Hmm. So whenever we figure out that, hmm, okay, we use a variable here int last, int current, okay, int num2 is equals to I, and what would be this int num1. So if this is possible, then we need to do this, right? I mean, if the number is prime, then we're gonna do this. And we're gonna make num2 as I. What about num1? How do we initiate the value of num1? Okay, let's think about it clearly. We need to, I think the best way to solve this question is using a hash map. And how? We'll be storing, okay, let's break this clearly. Let's take a hash map. hash map consisting of a pair, I mean an array, or can an array exist in a hash map? Let's check and the difference. Can I store an array in a hash map? Yes, you can store an array. That's great. How? Yeah, it's the same thing. Okay, int array, comma, integer map is equals to new hash hsh map. So now we have got an integer array and a map. Okay. The thing is, we don't know what the latest number will be. Okay. If we can track the numbers, we can easily insert into the hash map with their difference, right? So let's do one thing. We are iterating in the numbers. So when we are iterating, we can know that, hmm, let's take the min difference thing, these things away. See, we'll take two numbers. Int nums1 is equals to 0. Int nums2 is equals to 0. See, now whenever we get a prime number, we name it, uh, we take that array. What is that array? Int result is equals to new int of 2, which is 0 and 1. Nums1 would be the index 0, nums2 would be the index 2. So now, if a number is prime, what should we do? If we figure out that a number is prime, it would first actually be added into the result of 1, right? Result of 0. So result of 0 is equals to a, which automatically would be this. Hmm, this doesn't make sense to me. We can do one thing. We can make this hmm, nums1 as a, and we don't know what nums2 would be. For the first iteration, nums1 will be a, and what would be the nums2? Nums2, we don't know. Okay, nums2 would be 0, right? Let's take that shit. Hmm, I mean, nums1 will be 0, so nums2 is taken. After this iteration is done, then int nums1 would be nums2. See, at every iteration, we figure out a prime number, right? After figuring out that the given number is prime, what we need to do? We need to insert it in the resultant array, and that resultant array should be inserted in the hash map. Okay, let me clear this out. Have a clear mind. Figure out the prime number, add it in the result array in nums2 position. Nums1 will be the previous nums2. Add resultant array to hash map with difference as value. Now, is it possible for us to make this work? I mean, see, if we want to add result, it is in nums2 position. Nums2 should be the current result. Okay, we'll do one thing. See, when we figured out the given number is prime, what we will do? We will just take, we'll allot nums to it. Nums1, nums2 will be I. Okay. Then, as per our norms, result of 1 would be nums2. Hmm. Then again, what would be result of 0? Since we don't know anything. Result of 0. Result of 0 would be nums1, right? And then what we can do after figuring this out, nums1 will be nums2. Result of 0 will be nums1. Result of 1 will be nums2. And then we'll add this into the hash map dot put. What is this? Result, comma, the difference result of 1 minus result of 0. This is what we're gonna put into the map. If it is prime, then this is what we're gonna do. Initially nums1 is 0. Okay, then now if a number is prime, so the result contains nums1 and nums2, and now its difference also. So our hash map contains the prime numbers array and its difference. And what next? After getting this, we need to figure out the minimum difference. How are we gonna figure out the minimum difference? Keys with minimum value needed to be figured out. How can we do this? Case with the minimum value. We iterate our hash map again, right? Hmm. Now let's check this. Array list of, we take array. I mean, take this, I guess. Hmm. Equals to new array list. So keys with minimum value needs to be figured out. Now let's iterate over the hash map. Int min diff is equals to, let's check what is integer dot minimum syntax in Java. I'm sorry, I forgot the syntax actually. Don't remember. Yeah, integer dot min underscore value. Integer dot max underscore value. This is done. We have the minimum difference here. Now we need to iterate over the hash map. So again and again, I'm forgetting the same concept. How to iterate over a hash map. I have been using hash map in most of the questions, but I don't know how to iterate over a hash map. This is fun, and I need to learn it. Hmm. In Java, you can iterate in multiple ways over a hash map. How? Using entry set. It is recommended. because it gives access to both keys and values. See, now map.entry integer string entry. So this is how we're going to iterate. Okay, let's check. For map.entry, will it be in small or capital? Map.entry is the syntax here, and map.entry set. So this is the thing that I need to remember. Map.entry set. What is it here? Int of this, and this would be integer, integer, entry map.entry set. So here what do we need to do? If we want a key, we can use map.getKey. If we want a value, we can use map.getValue. Right. So now, if we remember this one thing, if map.getKey, if map.getKey is less than min underscore diff, if the difference is less than the given minimum difference, then it means that uh, we need to figure out the minimum difference first, right? So let's figure out the minimum difference. So even then we can't find the minimum difference directly. Hmm, heck, I'm not getting this. See, I can't do this on my own. But let me try it one more time. Map.entry set is a good thing that I need to remember. If map.getKey is less than min difference, we need to figure out the min difference first. Min difference is equals to map.getKey. Okay. Hmm. So we will be figuring out the what we say map.get difference. I mean the minimum difference. Now if we want to access all the keys with a certain value in an hash map, how can we access it? How could we access this? This can be accessed using entry set approach only. Just as given, we will be looping it again. Okay, for each loop, see, the better way is always the way this one, entry set. So let's use the entry set approach here. And if this is the case, mm, okay, the only thing that we can do is we'll be using again map.entry set. Okay, let's do this again. Mm, mm, mm. If map.getKey equals min difference a dot add map dot get, oh god, it's not get key, it's get value. It's if it is for keys, we're gonna use key. preserve value, we are going to use get value. So map dot get value here, and here map dot get value equals to the minimum difference that we need. We are going to add the map dot get key here, and then we're going to sort this array list. Okay, how to sort an array list based on the first element of the arrays inside it. Based on the first element of each array, collections dot sort with a custom comparator. Okay, so we're going to use array of 0. Okay, so this is the best that we can do. Let's do this. Hmm. A dot sort. Hmm. So we don't know what. Now we're going to access system.out.println how to print the first element of the array list. State of 0. Okay, that's correct. Hmm. So now return a dot get 0. So pretty messy code. I don't think it will work. Let's check. Public boolean. Why it is wrong? What's wrong in this? I don't get it. Oh, spelling mistake. Hmm. Map dot. Oh, sorry. It's entry. Entry dot get value. Since we have written it as entry, we should use entry. Entry. And here also. Entry. Entry. Hmm. Even then, we're getting output as expected is 11 and 13. We're getting 17 and 19. Why so? If we can, let's print a. Will it work? System dot out dot println a. Oh God. Okay. Oh, in a. How to print an array list of arrays. Array dot toString. Okay. Mm-hmm. Int array of list. Hmm, this is actually I of e. Right. Why we are getting only 17 and 19 here, and here 0 and 5. Okay, output will be the initial case 0. 5 is the first prime number. I is equals to left. I less than or equals to right. I plus plus. If it is prime, map dot put result. There is some terrible mistake in my code and I'm unable to figure it out. Debug this. Hmm. Using res for multiple pairs. Res is a single array and you're reusing it while storing it in a hash map. Since hash map does not create a copy of res, all stored references pointing to the same memory leading to incorrect behavior. Oh, okay. Hash map of int is incorrect for storing unique integer pairs. Arrays in Java do not work well as keys in hash map since the equals method doesn't compare element values by but rather memory references. Instead, use a list of int or a tree map to track pairs efficiently. So this is a valid point that I need to remember. Incorrect prime checking method. Oh god. It does not return false for num equals 1 which is not prime. It checks the divisibility only up to num minus 1 instead of square root of num, making it slower. Should return false for every number that is greater than 2. Okay. Sorting logic can be simplified. Map is unnecessary for tracking the minimum difference. We only need to track the closest prime pair while iterating. So what does this do? Let's copy this code. Let's take this in. Yeah, I know I messed this up, but let's do this again for my satisfaction. Well, yeah, it's passing. But let me check what he has written. So we have taken a list of pairs and list of array which contains the pairs. Previous prime is minus 1 stores the last prime found. Minimum difference is integer dot max value. Result will be this. So it's an array, right? Int I is equals to left, I less than equals to right. If is prime, then previous prime not equals to minus 1. Then int difference is equals to I minus previous prime. Pairs dot add. Okay, update minimum difference pair. Now, if the difference is less than the minimum difference, then we're going to update the minimum difference pair. Minimum difference equals to difference. Result equals to new int of. See, we are making a new array. We're not modifying the array itself. So that makes the difference here. So we're making a new result array if the difference is less than the minimum difference. previous prime equals to I since we are updating it. So for prime logic, if the number is less than 2, return false. If the number equals to, return true. If the number is divisible by 2, then return false. And here we are checking if the number, okay, this is great. So do this. Okay. It suggests that this is a very pretty bad code. Let's read the editorial for what we have missed. See Aferestinus. Okay. When a question involves prime numbers, it does definitely mean that we need to use sieve of Eratosthenes. Sieve of Eratosthenes is an optimal algorithm which figures out the prime numbers between two numbers in big of n range. This is a variation of sieve of Eratosthenes. We are given two numbers and we need to find the pair of prime numbers within the range such that their difference is minimized. If multiple pairs have the same minimum difference, we return the one with the smallest value. If no such pair exists, we return minus 1, right? So a simple approach would be to iterate through all numbers in this range. Check whether each number is prime, store the primes, and then determine the pair with the smallest difference. However, checking if a number is prime requires verifying that it has no divisors other than 1 and itself. A naive way to do this is to test the divisibility for all the numbers. Yeah, that's what we did here, and that didn't go well. Now what happens is, but a more optimized approach would only check the divisibility up to square root of n. This is what we have done. Even with the optimization, the approach was too slow. Since right can be as large as 10 to the power of 6, iterating through all numbers and performing a divisibility check for each would still be inefficient, leading to a time limit exceeded error. A much faster way to find all prime numbers up to a given limit is sieve of Eratosthenes. Instead of checking each number one by one, the sieve marks multiples of each prime in a bulk, eliminating the need for repeated divisibility checks. We start with a list of numbers from 2 to 100. Notice we skip 1 since it's not considered as prime. Starting with the smallest prime, we know its prime 2, we know it's prime because it hasn't been marked yet. So we keep it. Now we cross out all the multiples of 2 like 4, 6, 8, etc. because they are definitely not prime. The next number that isn't crossed out is 3. So we mark it as prime. Yeah. And then we strike out all the multiples of 3 like 6, 9, 12, etc. We keep going, find the next unmarked number which will be 5 and marking all its multiples. We do this for 7 as well as continue until we have processed all the numbers up to the limit. The beauty of Siva Parastinus is that it saves a lot of time by marking all composites in bulk rather than testing each number individually to see if it's prime. By the end, any number that's still unmarked is a prime. As we proceed, we collect all the numbers in an array, prime numbers, where save of prime will be 1. So, array index would track prime numbers. For any marked non-prime number, we could also keep track of the specific prime that marked it. So for the problem, it's sufficient to identify which numbers are prime. Since all values lie between 1 and 10 power 6, we can iterate through the array, check the minimum difference between two consecutive primes and return it answer. Okay, let's see this. Hmm. Now, main function closest primes. Generate the prime numbers using sieve. Create an array sieve of size right plus 1. Initialize to 1, indicating prime numbers. Set sieve of 0 and sieve of 1 to 0, since 0 and 1 are not prime. Iterate through the numbers from 2 to square root of right. If the number is marked as prime, sieve of number equals to 1. Mark all its multiples as non-prime. Collect prime numbers in a range. Create a vector prime numbers. Store prime numbers within left and right. Iterate through the numbers from left to right. If C of num equals 1, then add num to prime numbers. Find the closest prime pair. If prime dot number size is less than 2, we are going to return -1 since there are not enough primes to compare. And we're gonna initialize minimum difference to maximum integer value and closest pair to -1 comma -1 because they're going to be the default values. We iterate through the prime numbers and check the consecutive primes. Compute the difference, and if the difference is smaller than the min difference, we update the closest pair. Else we don't, and then we'll return the closest pair. Here, if you see something, we're not actually storing pairs. We're just comparing the numbers and creating the array itself there. And I mean, we're modifying the array. We're not creating new array for each pair. That's a naive method that I have used. Return closest pair as a result. Helper function would be see. See what happens here. We copy this, paste it here. Hmm. Complexity analysis. Wow, this is cool. There is also something called analyze distance between twin primes, which I will be discussing in another video. Okay, this is really a good question to be done. Okay, so let's discuss about this approach first. So here we have taken an sieve array and a prime numbers array to store all the prime numbers in the range for num. So here we are making prime numbers dot add. I mean, if we are checking if C of array of num equals to 1, then we are adding it into the prime numbers. But here, let us also check one more thing. If num is equals to left and num, I mean, we are checking the num range here, just using a for loop, and then we are checking what is the corresponding value of the number in the CU array. If it is 1, it means that it is prime, so we are adding it into the prime numbers. If the prime numbers dot size is less than 2, then we are returning the default array with the minimum difference equals to integer dot max value. This is what we have initiated this with, and then the closest pair would be the array that we are going to return. Arrays dot fill. Let's check what does this method means. Okay, this actually means it is a initial value. Let's check this here once. Uh, explain. So let's check this. So here we can see that this method in Java is used to assign a specific value to the elements of an array. Breaking down, closest pair is an integer array. Statement arrays.fill sets all the elements of the closest pair to -1. I use arrays.fill default value setting. In Java, an int array is initialized with zeros. If -1 is used as an indicator for no valid pair found, then filling the array with -1 makes it easy to check later. Okay, so this is why we are using this. Arrays.fill basically means that we are filling this array closest pair with -1 initially. We actually had an array as closest pair which initial values are zeros, both are zeros. But now we want to fill it with -1. Since if there is nothing left, we will be getting -1 as the output. Next, for int index I less than prime numbers dot size I plus plus, we're calculating the difference. Prime numbers dot get index minus prime numbers of get index -1. So basically he used a direct for loop calculated the difference, and then if the difference is less than the minimum difference, he's just making the min difference as the difference, and the closest pair array would get these values, and then he's iterating these in a for loop, so he will return the closest pair. Now let's check how the sieve array is filled. This is also a main logic that we need to know. Here int sieve is equals to new int upper limit plus 1. Okay, I take and initialize the sieve array first and second element, since 0 and 1 will be not prime, so they are initialized as 0 0, and then from 2 I square less than equals to right I plus plus. Here what we have done is, if the number is 1, then for int I is equals to number into number, I mean int multiple equals to number into number. Okay, this doesn't make sense. Wait, let me check it clearly. So if the number is 1, we need to mark all the multiples of number as non-prime. Int multiple equals to number into number. Okay, multiple less than upper limit. Multiple plus equals to number. Okay, okay. We're taking number square here. What is the number? 2. If 2 square is 4. 4 plus multiples of 2. I mean, int multiple is equals to, let's dry run this code. We don't know what the number, okay. The number is 4. 4 less than upper limit. 4 plus, the number 4 plus plus. Okay. So it runs from 2 to 4. Initially the number is 2 into 2, 4. If we take the number as 3. So number runs from 3. 3 next will be 4. 3 is multiple. We need to have the multiples, right? So multiple plus equals to number. Oh, that's what makes the multiples here. Hmm. This is basically a for loop here. That is why I got, actually my brain didn't work. It's actually a for loop. Just look at it clearly. So multiple less than equals to upper limit. Multiple is equals to multiple plus number. C of multiple is 0. Now it's clear. So that's how this algorithm works. C of Erasmus. A worthy algorithm to remember actually. Yeah. So this is approach 1 using C of Erasmus, guys. Thank you.